Okay, for people who are joining this live stream, this is a meeting about language completeness and consistency, and we have a variety of topics here. So first one is $timed out, which has been used in various places.
Right. Well, that's the very interesting thing about it, that when we did our survey, we actually didn't come up with very many places that actually use it. And we briefly started talking about this last time, right? So low-level evaluation-related functions return $aborted. So let me actually start at the beginning. $timed out was documented in version 7. But I think the only function that we have found that actually returns it is ping time. And it's used internally in a couple of places, like people decide internally to pass around, but things like, a URL download or whatnot, if they time out, they return a failure object. And so
the difference between aborted and timed out is aborted was actively stopped.
Right.
I mean, timed out in a sense was actively stopped too, although it more refers to some external thing. Time constraint is like we were running, it just didn't work. Whereas timed out is more like something out in the world was supposed to happen and it didn't happen.
Right. Right. So in the ping time example, like we sent the pings, we waited, we never got a response. So we just gave up after whatever period of time.
Right.
Whereas time constraint, it says, once 1 second has done, you will stop whatever you're doing and propagate in the $aborted to the outside world, because I've told you can only spend 1 second even trying to do what I'm asking you to do.
All right. So look, URL download would be a candidate for timed out. It just doesn't happen to use it. Whereas find equational proof is absolutely not a candidate for timed out. In other words, timed out is it wasn't our fault.
Right.
Whereas aborted is it was something happening internal to our system and we've chosen to kill it. Okay.
So say that last sentence again. I feel like
probably because I'm eating a piece of chocolate. Okay, but I mean I'm saying timed out is something was supposed to happen in the outside world and didn't happen, not our fault.
Right.
Aborted is it was something happening within our ecosystem and something chose to abort it.
Right. You're right. And that something could be a user pressing abort, or it could be the user chose to use time constrained, or internally we
yeah, I mean, I'm not thrilled that the behavior when you press abort interactively and when there's an internal time constraint is the same. I'm not thrilled about that. I think it'd be better if it was different. But okay, so what's the question here?
Right. Well, the question is, what do we want to do with this symbol?
Right. Do we want to phase it out and return and instead use failure objects, or do we want to? So look, I mean, again, okay, this question about timeout, boy. I mean, there's a whole class of network timeouts, basically. And then the question is, if it's in the cloud, when it's sort of all on us, does it count as an external timeout or not? I'm beginning to think it might be better to phase it out.
Mm-hmm.
I have the impression that $timeout is like a sibling of $failed. And in the same way that now we can use $failed or failure, I think this could be some sort of possibility offered to users, and they can use $timeout or failure for expressivity.
Maybe. Yeah, maybe. Okay, I don't think this is a pressing issue, at least.
No. It was a question that was posed at some point, and we had an answer, so we brought it back.
Okay, fine. And the answer is it isn't used very much.
Right.
Okay. All right, let's keep going here.
Okay, so this is probably just a bug, I think, or a couple of bugs, but there's right. So there's an expression with two associations in it, and if you use AssociateTo, then it sort of works, but it doesn't return just the expression that was modified. It returns all of expression.
That's just wrong, isn't it? I mean,
yeah, it's certainly
it's just
right.
Wrong.
It's an what?
It's just wrong. I mean, any expression that has a L value, is operated on with an R value, it should return the R value. In other words, because
no, it doesn't return the R value. It returns the L value that was actually modified. Right? If you do part of whatever
fair enough,
equals
fair enough.
whatever.
But it's like saying I plus equals 2. It returns it returns 3 or whatever.
Right. And yes, and if you do X part 2 plus equals 2, it'll return whatever is the result of adding 2 just to that part. And this is right. So the append 2 is correct because it's showing you the result of applying B just to the second association, whereas AssociateTo seems
just wrong.
To be
it's just a bug.
Right. And right. And then the second issue is that right, it's not evaluating the L value parts at all. So you have to inject, right? So when I did the when I put in a literal
that's wrong.
one, it
it's
worked.
Just a bug again.
Okay. Yeah, the AssociateTo was let's just say the AssociateTo ref page is pretty sparse. So just wanted to bring this up.
Raising another question Ethan is raising on our live stream. Efficiency of append to. Now, clearly in modern times with the queue data structure and so on, linked list data structures, we could make it efficient.
Right.
I mean, in other words,
although I don't know that append 2 will act directly on a data structure, right?
No, it doesn't. But I mean, what I'm saying is that we could, in principle, with some weak hashing method or something, we could, behind the scenes, be doing that. I mean, we've talked about this for years, and it was one of the objectives of the compiler project to be able to do this. And, in some time in the future, when we have just-in-time compilation for things like this, that might happen automatically. But I think it's worth the question to the compiler team whether there is some way, using weak hashing or some such other thing, if you've seen an append to happen many times on the same expression, right? Maybe you should maintain something and the results not be looked at. Maybe you should maintain something that allows you to, to do those updates efficiently. Do you see what I'm saying?
In the context of function compiler, I'm not quite sure.
In the context of the system in general. I mean, just like we have a bunch of cached and data structures that help us do certain operations faster, usually using weak caching methods. This will be another one of those.
Yeah, your statement is that if the system sees append to C, comma, element happen over and over and over again, but no reads of C other than inside the append to, then C should be temporarily replaced with an internal bag until such time as
or in fact, C would just become something which is, colon equal to a bag unpacker.
Yeah.
Right. It would actually be colon equals C equals bag unpacker.
Yeah.
So as soon as the thing is unpacked, it's gone. But yes, that would be the idea. Let's raise that question. I mean, this is more of a Mark, etc. question.
Well, I agree with that statement, but I will just add the observation of, that involves changing the evaluator, right? That's not.
No, it doesn't. No, it doesn't. It involves changing append to.
No, because
doesn't.
your statement was noticing that C is never read and is only append to it.
I think there's a way to do this. Let's not solve that engineering problem in this meeting.
Okay.
Yeah. Okay.
I'm skeptical, but all right.
I think there's
right, and there's also prepend to and what if it's interleaved append tos and prepend tos, but nothing else.
You know what? I bet there's a way to do it. You want me to invent?
No, I'm not. I'm pointing it out as things to include in the discussion. I'm not.
No, I agree. Yeah. But I think there will be a way to do it that uses, for example, I don't know, noticing reference counts the last time it came through, that type of thing. Okay. Having some table somewhere that I don't know. I mean, I don't know how to do it, but I'm not inventing the engineering solution right now. But I think it's been a persistent problem that has been something which for a decade we've said we're going to fix this with compilation. So now we have a certain level of compilation, we could fix it. So let's, if nothing else.
I see what you're, okay. I think I didn't understand what you were suggesting at first. So you're suggesting that we create, because of the compilation, we can create a data structure that append to can refer to speed things up.
Yes, but it would be invisible to the user.
Right. Yes, I understand. Okay, I understand the suggestion now, and I agree. And I think we're working on things like this for like numerical evaluation. But yes, this is definitely a question for Mark and Rob and Tom.
Right. And Ethan is saying shouldn't have to use internal stuff bag. You don't. You just use create data structure of Q. Is Q the right data structure? I don't even know. Or is it linked list?
Well, it depends on whether you just want to append or
yeah, right. So linked list
or do both. Right. If you want to prepend and you need a linked list. And of course, the other way to do this is with reap and sow, right? Reap and sow are the sort of the pre-compiled way to do it.
Right. I mean, if we do this, let's see. What are we saying? Append. I mean, this is my not very favorite design here of how this works.
Right.
Is this doing this right? If I just do that 5.
That looks correct to me.
Okay, there we go. So why? Oh, I see. Okay, brilliant. All right, so now let's do the test that Ethan is proposing we do here. Whoops, what am I doing here? I wanted that in the do. Thank you, syntax coloring. That's respectable. Now, let's watch it be not very respectable. Let's say CC equals null list. This is going to be absolutely horrible.
Yeah,
I'm not going to even use 10 to the 6. I'm going to use 10 to the 5. grind, 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 grind. But you see, this is what we could do if we had a hidden connection to CC to this queue. It will work beautifully. Obviously, for the user, if they already know what's going on, okay, so that's totally horrible. That's like 200 times slower. So, horrible. But anyway, let's raise this. If nothing else, can we make sure it's in the next compiler meeting, please?
Yeah,
So
I got it.
do that. Okay. Ethan is commenting that there are timeouts related to dynamic as well. Options like dynamic evaluation timeouts. That's interesting. And I'm not sure we understand how. Yeah, dynamic timeouts are a whole different story, which probably nobody in this meeting particularly knows about. Is that a true statement?
When I was telling John last week how bad I am at dynamics, he said, well, I'm probably in the top 100 in the world. So,
well, look,
right.
It is an interesting question whether we should review sometime. I mean, the whole mechanism that, of dynamics and the way that dynamic tickling works and all this kind of thing, I don't think we've looked at that for years. And, I think it's pretty clever, but, I kind of wonder whether with modern methods and modern, like, for example, the refresh times and, the whole callback mechanism when things are modified, is that obviously right? Or could we, the shocking thing everybody says about everything is, use machine learning to figure it out better, although that usually doesn't seem to work well. But, this question of what should the optimal refresh time be for this particular thing, there are times when, for example, I have a notebook, it has lots of dynamics in it, it slows to a crawl, and the fact is I'd be happy to have my dynamics, it's not doing the correct scheduling / load balancing. I'd be much happier to have my dynamics be slower, but by notebook not slow to a crawl, if that makes sense.
Right. Although that is a function of how people chose to write their dynamics, right? They can choose them to be preemptive or non-preemptive. And if lots of people decide to all be preemptive, then
which is the default, right?
Depends on how you generate the dynamic, but yes.
Probably more than I know. I mean, as in, I don't mess with preemptive or not in dynamics ever. I'd completely forgotten about it. Now that you remind me about it, I remember. But I don't ever mess with that. So, if there's something there that needs to be thought about, I think that should be exposed.
Right.
It might be a good topic to discuss.
Okay, it's right. Obviously, we would need John for that.
Indeed. All right, let's go on.
Right, so we started talking about this next item last week, or I guess 2 weeks ago.
Yes.
And I think
Do we think we resolved it or not?
We think we agreed on what the issue is. I don't think we agreed on what the name of the new option is.
Okay, and I wonder how this relates to tree mapping, which we've been discussing today.
Well, that's a perfect question for Ian. Ian? I was at the new in 12.2 webinar, so I missed the ILD meeting. So you might need to bring me.
Well, the main issue is mapping onto data payloads or mapping onto subtrees is one of the key issues of tree map. Is Ian with us here?
Yeah, I don't think this issue connects with tree map, but maybe
okay,
I'm not seeing
fine.
it.
Okay, so the proposed new item, this is accounting for head structure in determining levels. Is that correct?
Correct. And sort of in both halves of it.
What do you mean by both halves? You mean that when you say -2, Well, this isn't saying minus.
There's which parts of the expression do you look at, and then there's the separate question of how do you measure the depth of a part of an expression.
Right. How do you measure the depth of the expression altogether? I mean, heads arrow full will be measuring depth, including the heads.
Exactly.
Right.
I think full is better than all.
Okay.
I mean, I would say the description is something like includes heads in full or something. And so the idea would be then, if I say map all heads arrow full, then I am burrowing all the way into the heads. Is that correct?
Well, so this only determines what you consider to be at a negative level.
What about deciding where I burrow?
So if you say a negative, like level -2, which parts of the expression does that refer to?
No, I understand that, but I'm asking this.
Right. So map all applies to all levels. So map all doesn't, this new value doesn't make sense for map all. It would for map.
Wait a second. If I say this, oh, I see. That's already rodentifying into the head, so to speak.
It only affects negative levels.
No, wait a second. So map all normally doesn't burrow into the head, right?
Correct.
But with heads to true, it burrows.
Yep. Right, but map all applies to all levels, so it doesn't matter how you're measuring the levels, right? The issue is that if you're only counting down from the top, then you're counting down from the top, and the only question is, do you enter the heads or not? If you're counting from the bottom, then you need to know how are you measuring the depth.
Yes.
So wait a second. So in this case, I was at level -1 inside the head, right? So how would this be different if heads were full? Guys, how would this be different for this map at level -1?
At -1, it
might not be different.
It might not be different because you're only taking basically atoms, including inside the heads. So you need sort of -2.
What the heck did this do? What did this even do?
Right. So it's finding multiple parts inside the head because you said head goes to true, but it's considering them all to have depth 2 as if you had heads goes to false. So it repeatedly applies F to those parts that you find in the head.
Right. I mean, I do have some examples in the previous section.
Okay. Fine. But by the way, this should be somewhere in documentation. This is really confusing. So what you're saying is that in heads, level -2 could actually apply to multiple levels. Like, in other words, my definition of a level is if I say position of that, comma F, oh, for goodness frigging sake, why doesn't it get all of them? There's more to this. This is more of a mess than I thought. Oh my gosh. Okay. So why exactly are those?
Because A of B and A of B of X both have depth 2 with heads goes to false.
Really? Oh, because I see they have. Really? Why do they have depth 2?
You don't consider the depth of the head.
Okay.
They're both head with one level of arguments.
Oh boy. Okay.
Right. This is why this only applies to negative level specs.
Mm-hmm.
Right. When you say positives, when you give a positive levels, you're counting down from the top. When you give a negative level spec, you're saying, well, the depth of this expression is blah. So, but then you need to define, well, how are you defining depth? Are you doing it with or without heads?
Okay, but so heads is actually doing two different things, right? It's determining whether you go into the head with a map, and it's determining whether you count heads for purposes of negative levels, correct?
Yes.
It's always
Right.
a bad idea when these things do two things.
Right. So the other
And for example, some functions don't have the second case, right? Like map all. Map all, the heads is only doing that first function.
Right. So I
So
suppose
it's kind of like head levels, arrow, whatever. Heads, arrow, whatever. Head levels, arrow, whatever. Or we could decorate the -2.
Right.
Which
Or
might
like
make more
head
sense to me.
depths.
What's that?
Or maybe the option is like head depths goes to true false.
I see. That would make more sense. Well, it's head depth goes to all, or head depth goes to 1, basically. Right? Because in one case, the head depth is always 1. Is it not? The depth of a head with heads goes to false is always 1. True?
No.
No. Right. It depends on how many things it has inside of it.
But in the case
I see. You're saying
negative
just the heads part. Oh, I see what you're saying. It's that might be true. I'm not willing to promise that, but yes, that does sound believable.
Okay. So, I mean,
I guess the question is, if we had this as an independent option, would it have any effect when heads goes to false? And I don't think it, well, I guess.
I think it would not.
Yeah, I don't think it would.
Because only negative levels are considering the depth.
right. Well, I mean, the settings will be basically head depths to 1 or head depths to automatic. Or all. I mean, in some formal sense, but this is getting way too overthought. It's kind of like a head depth function. Although I'm not sure that this is right. I mean, in other words, if I say, yeah, a head depth function is saying it's always 1. So any -2 or something is already way above the head, so to speak, in over its head.
I'm not understanding the 1 versus all.
Okay, so I'm saying that what is the case is that you always return. If you say, what is the effective depth of this head? The answer is always 1 if you're not going inside it. Or is it always 0? Look, what gets you to level -1 without, okay, in this case here, let's see, this is level, boy, this is confusing. Okay, that's level 1 in there. Okay, so now I say heads goes to true. Okay, confusingly, every piece here, A of B of X, everything is treated as being of depth 1. And the F's are sprinkled on that basis.
No, it's that A is depth 1, B is depth 1, X is depth 1, B is depth 1, C is depth 1. It has nothing to do with A of B of X because we're looking at -1.
All right. Okay. So what's the minimal example that is affected by this head depth thing?
You had one level -2. I think that's N of 515.
Oh, but you can also look at if you want to look at expression.
Yeah, we did make.
Yeah.
Where is this?
So I think it's at the top of this section. There's an expression. Oh, I guess you can't necessarily, well, you can't evaluate the pictures because this is not a prototype build, I presume, but.
No, it's not.
But right, so there I added right, so I have heads of heads, and I have heads in a couple of, compound heads in a couple of different places.
Oh boy, guys, this is really a head scratcher, a detail. Okay.
I think the example I put in chat is a minimal example.
Okay. So what am I supposed to do with this thing?
So try map.
And I guess we'll map
something
X
other
or
than
something.
F. Yep. And then do -2 for the level.
Okay. And then do that with heads.
Yes. Right. So the entire expression has depth 2 because it has one level of arguments, but so does f of g of h because it has one level of arguments, and so does f of g because it has one level of arguments.
Okay. So as Sandra is pointing out on our live stream, and this is the point I was making too, this is very weird, right? This is my point about one of them is head depth is a constant, right? Because I could go here and, do that. It's still 2. Now,
Well, two heads goes to true for depth.
Right. But now is this head depth thing relevant for this or not?
Well, that's why I was thinking the option would be head depth goes to true or false, because it's specifying whether the depth function, whether its heads option is true or false.
I see.
Right, right, because depth is depth is counting from the top always. It's just a matter of, does it actually enter the heads to look inside of them to see if there's secretly something deeper hiding inside of a head or not.
All right. Head depths, maybe. Arrow true or false. Whether to count the depths of the head in working out negative levels. You know what I find interesting about this? A person who worked on SMP invented negative levels in maybe 1980. Okay? We are now in 2021. I don't believe this issue has ever come up before. I mean, unless you guys have been harboring this issue for years. Unless this is bug number 13.
No. The reason this came up is because he's working on trees. And when you work on the tree, when you look at the trees, you sort of see the issue specifically.
Fair enough.
And
Okay.
it pops out.
But we've survived for 41 years without such an option.
Nobody is suggesting that we must drop everything to implement this right away. But since we're thinking about trees, right, we should think about it in this context
the
also.
Lifespan of all programming language development. That this has been not there. All right, I suspect head depth arrow true or false, or head depth, sorry, arrow true or false.
Okay,
makes sense. All right, this is definitely in the tentacles department. By the way, when are we going to get our beautiful tree visualizations? Ian?
So we have a mock-up or several mock-ups from Billy that we're looking at, and Jose and I are working on implementing the actual tree. Like,
Okay. Can you throw me a mock-up in the chat? I'd just like to see one.
Sure. Give me a second.
Okay.
Right. So this was an email you sent to TLCC, and right. And I'm not sure what the basic problem is, though. So here we are discussing it.
Okay. The basic problem is, when you're dealing with formal mathematical relations, this is the difference between equals. We are so 100 years ago at this point. This is the difference between the meta logic and the logic. Okay. So what I mean by that is there is a notion of equality, which is just a communal garden predicate, right? Like primality, like this, like an arbitrary symbolic predicate P. And then there is I really mean equality, and it's part of my meta logic, and it's part of the way that I actually do computations and inferences and things, if that makes sense. Okay. That issue came up 100 years ago. It's biting us again now. So in other words, for axiomatic theories, we actually need two notions of equality. I think it comes up first with fields, if I remember correctly, that there's a notion of equality that is a pure predicate that's just like any old other predicate, which could also be an unevaluating function like plus or something. And there's a notion of equality that actually means these two expressions are equal. And I think in some sense, and this is where I go off into weird stuff I'm still trying to understand in higher category theory and homotopy type theory and all this kind of thing. I think that in the end, this univalence axiom thing is something about equivalence of those two things. But nevertheless, nominally, there is a notion of, I just mean the equality predicate versus I am actually trying to compute whether these things are equal. Okay, so we have a third meaning of equality, which is x single equals y, which means make it so. You see what I'm saying?
Right. Right. So there's assignment.
There's assignment. There's test it, and there's just I want this hanging out there like a list, like other kinds of things that I can operate on from the outside. I mean, the issue is it equality that tests from the inside, that on its own account says, I'm going to check whether these things are equal? Or is it equality that is merely hanging out to have things done to it from the outside? Okay. Now, practical matter, much more elementary things, you're making a table of, addition facts, 2 + 2 = 4. You'd like to have well, I mean, that one isn't going to work for all kinds of reasons, but yeah, I mean, that's going to be a hold form story at the best of times.
Or an inactivated story.
That's true. I see. So one of the questions will be, what about an inactivated equals? That's an interesting idea. So, I mean, what you're saying is if I said,
I have the impression that this would not be enough because equal and inactive equals are supposed to represent exactly the same thing.
And also that's not something that's super easy to type in, right? Really, the only way to type it in is to do an active of equal of blah and let
I know, but I mean, typing it in, we could solve a different way. If we really thought it was important to have, I mean, this is really formal equals.
Right. I think what is needed here is a way of having some formal operators without having to invade these operators that we have for the users.
Well, right. And you might say formal plus is another thing we could have.
Exactly. Yeah. So operators that we can use, for example, in axiomatic theory without having to invade
Okay, so I'm going to get more funky. What about
Right.
full
So for
zero?
example, we have like a dot equals character. So what's the argument? Are you saying that's something that shouldn't be used, Jose? And if so, why?
It's
Because,
fine
I
except
mean,
for its appearance. What's it? Go ahead.
so my impression is that we want something like we use formal A. It's something that the user, I mean, that couldn't, it cannot have been given meaning. But for dot equal, perhaps the user has already a meaning.
Okay.
Right. So if we had something that it's ours, but doesn't have a formal mathematical meaning, we could use it everywhere in axiomatic theory.
Right. So we could add a formal. Well, would this work? I think
We had a formal equal.
I think I think this would work. I mean, I would have to discuss with John to make sure I'm not missing something in terms of parsing rules, but we could create a formal equals that typeset similar, right, with the dot underneath, just like other formal.
How are we finding the dotty stuff?
I certainly like it better than this 2 dots. And
yeah, I know. The question is, are we going down to 0? I mean, you know, in other words, one thing we could do is make these things gray, for example.
Yeah, I don't. I'm not a fan of that because, you know, what if somebody, right? You know, what if somebody's putting it on a gray background or whatever, right? I mean, forcing colors is
But there might be a way
dodgy.
to do it with opacity that has. I'm
Right.
not super worried about that issue.
But
I would say it could be confused with inactive.
That's brownish.
I actually like, I like the dot, but that might just be me.
Look, the real problem with the dot is not its appearance, but typing it in.
Mm-hmm.
What happens if I do we have the alias?
Yeah, it's
a dot like that. No, we do not.
Dot A.
It's dot A.
Oh, I never used that alias. I should use that alias.
Yeah, we added that in 12.0, I think. I mean, we didn't always have it, right? It was $1. Was the, which still works, I'm sure.
I was gonna say, is there any reason not to have both as aliases?
You mean a dot and dot A?
Yeah.
I don't know.
I mean, I don't think, proliferating the number of aliases just because is a good reason.
It doesn't seem like a great idea. We might want to use it for something else. But
I mean, potentially it could also be improved through better auto-completion.
yeah, I mean, right now dot equal does that, but it doesn't need to do that. I mean, it could turn it into formal equal.
I always have a similar, sorry. I was going to mention that I always have a similar problem when writing the accented Spanish characters, like A with an accent. I never remember whether it's accent A or A accent. I have to try both.
That's interesting. Because on a like a keyboard, like at least I know a typewriter, you type the accent first, don't you?
Yes.
Not this.
Well, I mean,
certainly in Hebrew you don't. In Hebrew you type the letter and then you type the vowel.
Well, that's probably because that was invented. On typewriters there are dead keys, right? If you're going to type an accent, you want the accent inserted, but the carriage not to move, and then you type the character.
Exactly.
And I suspect that's been grandfathered to computers.
I mean, nowadays, at least on Mac, you can just hold down the A character.
I know, and it shows you a
which mainly that's for Jose's benefit.
I didn't know this. I always use escape and then try the combinations A randomly, and one works.
Mhm.
Yeah, I mean, it is remarkable, some of these little affordance things that one never discovers. Like, I'm embarrassed when I hear about things in notebooks that have been there for 30 years and I didn't know about it. Well, okay, so the question here is, okay, should we bite the bullet and introduce a collection of formal, we definitely, by the time we have formal Bessel functions, the world has ended, so to speak. We don't want that.
I don't think there's much danger of that. I mean, of course, you can inactivate Bezel J if you need to for some reason, but it'll just format as, Bezel, a brownish
Yeah,
Bezel J.
I understand, but I mean, formal plus, formal times, formal power, formal equal.
Okay, well, I guess the question is, what's formal power? Is that a caret? Because if it's a superscript, I don't know how you make it formal.
You have a little dot there.
I was going to say you turn the superscript gray.
Oh boy. No, I mean, I'm sure you could have a little dot in the sort of connector between the base and the exponent.
Maybe.
But I mean, my concern is, as soon as we're going formal with these things, we're going to go on formal left multiply, formal right multiply, and so on. Where does it end?
I would say formal plus, plus times and equals would be very useful. For example, non-commutative multiply is used quite a lot just to represent products.
Right.
And so,
but what if you have two kinds of multiplication?
Well, at least having one more would already, I mean, a plus that, for example, is not commutative.
Then you add non-commutative multiply, right?
Okay, what about negation?
But when we
could have formal minus, I suppose. Let me just wax ineloquently about this issue, okay? The basic problem is, I mean, this is a 100-year-old problem that we have managed to avoid for 40 years. That is, it's a what is mathematics type problem, because, we have a symbolic system. Yeah, I mean, okay. Basically, the point is this. In our symbolic system, things like plus have a built-in meaning. But we can imagine a completely devoid of meaning symbolic expression system. I mean, in a sense, this is the transition to the physics project. That the physics project is a giant, admittedly 2-level rather than infinite level, symbolic expression devoid of meaning, where the things that would be pluses and times are the ID of a particular atom of space, right? It doesn't have a known sort of centralized meaning. Whereas what we have been doing, I mean, we're imagining that our expressions, as we usually build them, are kind of meaning first expressions. Where am I going with this? I mean, manipulating expressions. Look, the basic point is, with something like list, here's my point. My point is, in some sense, we want to deal with expressions that just have structure without any meaning, without any content. But we need to know, just like we do in a graph, that blob there is the same blob as this blob here. And that's exactly what, in the whole hypergraph formalism. That's exactly what we're doing. We're just saying these blobs are meaningless, but we're going to tell you which blob is the same as which other blob. Am I making sense? As opposed to what we're doing in our language in general, which is we are connecting every blob here to a reservoir of meaning, if that makes sense. We're saying this is plus, it's connected to the central meaning reservoir of plus. Whereas here, all we're saying are which blobs have the same meaning, if that makes sense. Did that make any sense?
Oh, sorry, I was muted. Yes.
My view of this comes from axiomatic theory. So in the same way that in axiomatic theory we use formal A and formal X to avoid a conflict with the users A and X, we also use circle times and circle plus, etc. And there's a danger that the user might already be using them. So why not having some formal operators for us?
Right. But I mean, the other point is, in principle, formal plus for, look, what this really is undefined operators, which are kind of, which are kind of, okay, you could have two different pluses, right, in principle, both annotated. They're really anonymous operators, okay? That's what we're talking about. It's anonymous operators which are tagged as being, oh, this is supposed to be a plusy thing. You see what I'm saying?
Right.
So I guess that's the thing which we don't have. We don't have the notion of an anonymous operator. It's interesting, actually. It's an interesting concept. I mean, we do in a graph, we have an anonymous, we have, binary relations in a graph which are anonymous. You see what I'm saying? And with hypergraphs, we would have n-ary relations that are anonymous. Although even in the hypergraph formalism for the physics project, we just have a hypergraph. We don't have hypergraphs of hypergraphs, so to speak. But we could. Interesting. I mean, we have something more like that in the combinator world and so on. But okay, but let's imagine that we had a completely anonymous operator, okay, which is merely, clearly we can get that from our symbol table, but it's very inelegant. Just like it would be inelegant to label, we can have a graph that sits there as a graph without us having to say, oh, that node is labeled, 17 or something, if I'm making sense. Like you don't care what the names of the nodes are in the graph. So similarly here, what we're dealing with, and this relates also to trees, I suppose, is we're dealing with a tree where, again, if I make a tree, right? Okay, so here's a point. If I make a Carey tree, okay, there's a nice Carey tree. Actually, let me make it, let me make this a, okay, so there's my tree. Okay, that tree is very anonymous. It doesn't have any, its nodes don't mean anything right now. They don't necessarily labeled, or their labels are meaningless. But now if I want to actualize that tree as something that represents polynomials or something, then I'm going to connect those nodes to sort of the reservoirs of meaning that correspond to those things. Ruffian on our live stream is commenting about the relationship to type systems. I don't think, I mean, in other words, you could say, I suppose, an operator is of such and such type. I don't think that really helps you very much. I mean, I think it's the same issue as just saying this node connects to this other node, or is this making any sense to people? I mean, the issue I claim is we want anonymous operators, anonymous functions that have tags but not names, is my claim. And then we want transformation rules. Oh boy, what is this? I mean, clearly in our symbolic language, it's not difficult to represent this. I mean, it'd just be nameless of, tagging. That would be the thing. That would be, right? Is this making any sense? I mean, this would be the nameless object, but it could have certain tagging in it, which could cause it to have various kinds of print forms. I mean, again, you're not going to solve, by having a formal plus, we don't solve the problem of two pluses. Right? Jose is very silent.
I was thinking, so in my opinion, we would help in those cases, for example, in axiomatic theory, in which we need a plus, and we currently use circle plus. If we use formal plus instead of try, for example, group axioms, in which we use a circle times. Right. So my worry is what happens if a user is using group theory and he has his own group theory using circle plus already. We may break something.
I mean,
really what you should be using there is a formal dot, right? Which, is clearly distinguishable from a colon, but right. the conventional multiplication symbol.
No, but look, guys, what you're really saying is, you call it a dot, I call it a times, we call it whatever. None of those matter. That's the whole point. That's the lesson of 100 years ago, basically, of the development of sort of formal axiomatic theories, is it doesn't really matter. You can, what you call it is merely a matter of human convenience. I mean, that's in a sense, that's what makes our system possible, that we can have a symbolic system which manipulates generalized symbolic expressions without pre-knowing their meaning. Right. So, I mean, in this case, you say dot, I say times, somebody else says something else. All we need to do is to agree that these are the axioms. It doesn't matter. After that, it doesn't matter. All that matters is, it's a scoped thing. So long as I state my propositions in terms of that same thing, I don't care what it looks like.
Right, the visual is completely irrelevant. The important thing is making sure that these cannot have other meaning.
Oh, I agree. That's my whole point. That as soon as we have something, it's like this node here better be connected to this node, but not, oh, oops, that node has a name which connects it to this node. That's no good. Right, but we know that's no good in a graph. The collision of names in a graph is connections that shouldn't be there.
Right. So they are numbered internally, and that solves the problem. So, but it's
yeah, but it's a faux solution. I mean, it's like De Bruyne indices or something in lambda expressions. It's like it's just it's a bookkeeping mechanism. I mean, look, my attitude towards these things has changed since the physics project, because the physics project is a story where it's like these are the coordinates in space. We have these points in space, and yes, we can attribute coordinates to them, but they do not intrinsically carry them. And this is the same problem we're having here. That is, this thing, okay, is we are presenting it as a global axiom with its tentacles hanging out, so to speak. Really what this should be is more like an axiom function or something, in which this isn't quite right either, in which the operators are available, and this thing should be applied to this isn't quite right. This is not the right way to think about it, but it's something more like that, where there's localization of the, of these formal operators should be scoped. Look, the fact is we've got a problem with formal operators, and the problem is not new. It's just like De Bruyne indices and the problem of the naming of variables in, is not new. That one dates from, well, it was certainly understood as a problem by 1935. The question is, there's got to be a really good general way to solve this problem. And I claim that the way to solve it is something like there are expressions with nameless operators.
We could have a new character, nameless op.
Yes. But I mean, and it can have an infix form. It can have, see, what would happen if we have precedence, of course? That's another can of worms. Oh my gosh, that's a can of worms.
Right. And certainly, the front end and the language as it exists now can't really handle an operator of indefinite precedence.
Well, no, you can't have it. You can't parse. It's not our fault. You can't parse the thing of indefinite precedence.
Right. But well, okay, or let's say customizable. Right. I mean,
well, we know perfectly well, and we've already done it, that we can have precedence points, right? If you have a continuous, this is the question: is it's a kind of a Dedekind-ish problem, right? If you have a continuous range of precedences, then yes, that's a different story. Okay, if all precedences is an order relation, we can't handle it. As soon as we have, right? As soon as we say the precedence is 135, we can handle it. If we have a discrete number of precedence levels, right? But I don't even know. Is it the case that formally parsing just requires an order relation on precedent on operators? I don't think it can be enough. No, it isn't, because then you can have.
Right. You also need the grouping. So is it infix, prefix, postfix, and which way does it associate?
I think it gets even worse than that. If it doesn't associate at all, I think there's cases where it's even worse.
Yeah, we don't really handle that very nicely.
Well, right, but if when you have two operators, if you say A op1, B op2, C. And actually, boy, that can get complicated. Well, okay, so roughly, yeah, and that gets even worse if you have ternary operators, right? Of which we only have,
yes.
We only have tilde, right? No, that's not right. We have another ternary operator, don't we?
Well, we have things like tag set and.
Yes, that's right. That's a ternary operator also.
And I feel like there's something involving question marks somewhere.
Right. But okay, with ternary operators and the interspersing of order relations for ternary operators, good luck.
Yeah.
I've often wanted, for 30 years, I've thought about basically adjacency fix operators in a graph, where basically instead of writing an expression out in pseudo one-dimensional form, you basically are having, you're representing things, like a category theory diagram, but not really like that, because that's more structured. Again, you're just representing things by, you're trying to turn a graph into an expression. And actually, that's an interesting question, Ian, for your, tree expression, right? The question is, there isn't a meaningful notion of graph expression. There is a tree expression. There isn't a graph expression. Again, the thing we're talking about here is essentially a tree expression. Okay, here's an amusing idea. Trees have tagging information in addition to payload, right?
In what sense?
Well, I mean, they have.
Like options?
No, actually, that's not right. That's not right. They have.
It's almost like
They are just like
I was
expressions.
understanding the tagging that you're referring to be kind of like what we're calling the payload. Like you can have
Yes.
a carry tree, and yeah, there's 1, 2, 3, whatever, but you don't care.
Right. Instead, what you care about are the tags there.
Mhm.
There's an idea here, but I don't think we quite have it. I mean, this problem about formal expressions, we need to solve it, because this is, if we want to represent, so same issue where we've been representing. Let me give you another example. Okay. So, this is actually a pretty good example now that I think about it. Let's see if I can find it. Let's see. Okay, when we are looking at these formalized models of math, like lean and metamath, okay, they are just full of concepts that are defined only by virtue of, they're only internally defined, if you understand what I'm saying. Is this making any sense?
Right.
But yet we want them to be notationally, this is the mistake of Lisp, for example, that there is no notation. And when there's no notation, it's absolutely non-understandable by humans. So we want to get the best of both worlds. We both want something that's meaningless and that has indicative notation, if you see what I'm saying.
Yes.
I mean, when we have plus, we think we know exactly what that means. What we want is kind of the advisory notation of a plus, like the coloring of an edge in a graph as green or something. But it isn't really very, that's not really structurally important to it. The only thing we want here is that we want to identity of things to be structurally important. That is, we say that operator is the same as that other operator over here. Right. Honestly, this is I need to go, unfortunately, in a second, but this is reminding me of something I'm trying to figure out for sort of the bulk theory of metamathematics. This is closely related.
So this may be related, like with our symbolic representations of like topology definitions.
Yes.
Like in axiomatic theory, you're just dealing with the axioms, and so you have the operators that are present in the axioms. But in real math, you're going to have tons of definitional extensions to your axiomatic theory. And the way we handled that was by having like a symbolic math wrapper that you put a string inside, and then you would just have that somewhere in your big table and then define formatting rules for it.
Yes, that's directly analogous. That's the same idea. Right.
I truly see that the general problem here is hard, but in the same way that by having 100 formal variables or so, the Latin and Greek characters solves most of the problem for us, I was wondering whether having a few of the most important formal operators would solve most of the problem for us.
Well, okay, so one way to do that would be to say, yes, I mean, in a sense, one way to do that would be to say there's a way of inputting and outputting some of them, but internally they all work the same. They're all formal of payload, and that is treated as an atomic thing, but they're all, in other words, so that in principle you can generate a new formal thing, a new unique formal thing if you needed it. And, I mean, it's up to you could, for example, localize a formal thing somehow, so that, because that's going to be another issue, is that the collision of names of these things. I think we're actually making some progress on this formal Yeah, I mean, this is interesting. The Kove was commenting on the analogous to particles in physics. Yeah, this is same issue. I mean, it's like it's a proton, and they're all the same, but yet they're different type thing. This is a good idea. That there's some kind of formal thing that can take anything inside it that has certain. I mean, it's like our calculus of annotations for graphs. When are two graphs the same? When are they? But the annotations are just like for example, we have made the decision, right? We make the following decision, which is not an obvious decision, but we'll make it anyway. Okay, so if I say xx equals xx, and I turn that xx, okay, like this, okay, that will still be true. It's not obvious that that should be true, right? In other words, that annotation didn't matter to the meaning. And so similarly, what I would suspect is that we'll need some formal thing where there's two components to it. There's, both what fundamentally is it and what should it look like. So it might be, I'm really a group theory plus. That's defined as being a plus, that has its whole name, group theory plus. And it never conflicts. So if we have ring theory plus, it's not the same plus. But yet its appearance is, I just look like a plus sign, for example, or I look like a plus sign with some standardized annotation that means I'm a plus sign in appearance only type thing. Or maybe it's just a plus sign, and maybe there's some mouse over thing or something like that that indicates that it isn't. Maybe it has a slight indication of not being an ordinary plus. Okay, this is an interesting idea. We should continue it another time. I'm actually really liking this idea because it actually, as I say, resonates with things I'm trying to figure out about sort of the bulk treatment of metamathematics. It's always nice to be able to solve these theoretical problems at the same time one solves practical problems. But it's really interesting, Ian, that you've ended up independently inventing basically the same idea. So can we get this either another one of these meetings or an ILD meeting or something else to talk about, possibly even a custom meeting to talk about formal. I mean, we've tried this before, talking about formal variables, but honestly, I think now I've realized it's sort of a bigger problem and requires a more general solution than we've talked about previously. Make sense?
So to be completely honest, I got a little lost on what exactly the proposal is, but are you suggesting we need sort of a big meeting with John and other people, or do we think we
I
still
think
need
this
to
is
flesh out
more
this idea?
theoretical metamathematics stuff. I think that's the more the direction. I think in terms of the front endery, I think we can solve that.
Okay.
I think this is more theoretical math discussion.
So beyond Jose and Ian,
Michael will be a good person to have,
Okay.
possibly Jonathan.
Okay.
I mean, the axiomatic theory crew. Because
Okay.
they're the ones, and whoever Ian wants to bring in from the, mathematical structures world. And by the way, isn't this similar to what we have in the geometry, in the synthetic geometry stuff, where we have again this notion of a formal object that represents, the point A or something.
Not so much, but I see where you're thinking.
Right. The thing is terrible. I mean, I've been reading all this stuff that was generated in the 1920s about, and they were grappling with the exact same issues. The difference is they didn't have systems where they're actually implementing these things. So there's a whole bunch of philosophical stuff about this sort of symbolicizing of things, but they didn't have, it's like, who cares type thing. And indeed, it vanished without trace over the past 100 years. But now we actually have to solve it. So for another time. Okay, thanks all. I got to run. Thanks to folks on the live stream.